Hi everyone, it's Miss H, and today we're going to be looking at electricity. This is the first video in our final unit on electricity and magnetism, so this is just going to be our introduction to electricity. The next one will be looking at Ohm's law and calculations involving electricity, and then our final video will be looking at magnetism. So what is electricity? Electricity is the continuous flow of electrons. Electrons always flow from the negative end to the positive end, but the current flows in the opposite direction. So if we have our circuit with a battery here, okay, and this is our positive end of our battery and this is our negative end, okay, and then we have a little light bulb right here that's going to light up. Okay. Our electrons are going to go this way. Right, they're going to go from negative to positive, but our current is going to go the opposite. Our current is going to go from positive to negative. There are two main types of current. The first is called alternating current, or AC. In alternating current, the flow of electrons reverses directions at regular intervals. So this one doesn't really apply with batteries because batteries only have a definite positive and negative end, but more like with the electricity that comes into your home. So the electricity that flows through an electrical outlet regularly reverses directions, and so that's why excuse me, you have to be so careful with it, because alternating current is capable of traveling very long distances because it actually has a much stronger current. So that's why you don't want to go like sticking a fork in an electrical outlet, because it's going to potentially kill you since it has such a strong current flowing through it. The other type of current is direct current, or DC, or DC. In DC, electrons always flow in the same direction, so any battery-powered device uses direct current. This can't travel as far, but it's also typically safer because it's not as strong. So pretty much any portable device, anything that's battery-powered, is going to be using direct current. But the current that flows out of your electrical outlets, that flows through power lines, all that kind of stuff, is alternating current. There's a really fascinating history about the war on whether we should use direct current or alternating current to bring electricity into our homes, and I would encourage you to look that up because it really is really cool, but it's not something we have enough time to go into right now. So just know that there is a big difference between alternating current and direct. Alternating current is stronger, it can travel farther distances, it's what goes through our power lines, it's why you don't touch down power lines. Direct current is not as strong, it's not capable of traveling as far, but it is easier to use for things like portable devices and safer. So then what is a circuit? So a simple circuit is just any kind of closed path that allows electrons to flow. Typically when we're talking about circuits, we're talking about pathways that we create on purpose. There are pathways that are created accidentally. We call those short circuits, and those are bad. Short circuits are what cause things like electrical fires. So circuits have several parts. The first part of the circuit is the battery, or the power source. Okay. The second part of the circuit is the resistor. So this could be a light bulb or an appliance, anything that is going to slow down the flow of electrons. So resistors are just anything that slows down the flow of electrons, and sometimes we actually use a device that is called a resistor to do this on purpose, because what we're feeding the electricity through needs it to be slowed down. So if you look at like the air conditioner in your car, it has a series of resistors in it, and that's what tells it whether to blow high, medium, low, how hard to blow that air is by how much resistance is flowing through the circuit at that time. Next we have wire that we use to kind of connect all of the different pieces. The thicker the wire, the less resistance it has. If you think about it like a hose or a pipe, a big wide pipe or a big fat hose allows the water to flow more freely than a hose or a pipe that's really thin and narrow. Think about if you've ever used a gardening hose and you've put your thumb over the end of it to narrow down the opening, and it comes out a lot harder and it goes a lot farther than when you let the opening flow freely. So that would be kind of show you that resistance and that increase as it gets thinner. The longer the wire is, the more resistance it causes. Think about being stuck in traffic, right? The longer the traffic backup, the slower you go. And then some circuits, but not all, most circuits have switches. Switches allow you to open and close the circuit. So now when we put these into a circuit diagram, they have certain pictures that go with them, and we're going to look at those in greater detail in this course. So the battery is represented by two parallel lines. The short parallel line represents the negative end of the battery, and the long parallel line represents the positive end of the battery. So if you look at something like a graphing calculator that has 4 batteries in it, if we were to draw that, we would draw a series of 8 parallel lines that alternate between short and long. Okay, our general symbol for a resistor is a squiggly line that looks kind of like that heart monitor symbol. If we're specifically looking at a light bulb, that's that symbol I drew before. It looks kind of like a cursive E with a circle around it. You can also use a couple of other symbols there as well. And then different appliances all have their own symbols. So if you were to go into something like becoming an electrician or an auto mechanic or developer of some sort, you would learn all of these different symbols for different appliances and that sort of thing. But for this course, we're going to stick with, if it's a light bulb, we'll use the circular symbol, and if it's any other appliance or resistor, we'll just use the general resistor symbol. Wires are just any lines that are drawn that are not batteries, resistors, light bulbs, that sort of thing. And then a switch, when it's open, just looks like a gap in the wire. Sometimes you'll see circles drawn on each end to show it. If a switch is closed, it just looks like a wire. So typically if we're going to draw a switch, we're going to draw it in the open position. You'll sometimes again see either circles or lines drawn on the switch to kind of indicate that yes, there is a switch there, it's just closed right now. If a switch is open, the circuit is turned off. If a switch is closed, the circuit is turned on. So an open switch is because that creates a gap in the wires, so the electricity stops flowing. If any part of that wire isn't working, any part of that circuit isn't working, then you can't have electricity flowing through it because the electrons have to be able to get from one piece to the next. So when you close the switch, that's when you have it turned on. If you look at your power symbol on like the remote control where you have a single one, it looks like that. So that shows you the combination of the open and closed switch. If you look at like a rocker switch on like a power strip, you'll usually see a line on one end and a circle on the other. The circle representing the open and the line representing the closed. So to turn on the switch, you go for the line. To turn off the switch, you go for the circle. There are several different types of circuits, but they all basically come down to one of 3 categories. Okay, the first is a series circuit. In a series circuit, there's only one pathway for the electrons to take, so it's similar to like a baseball diamond where you have to go first base, second base, third base before you can come back to home. You can't go multiple different directions. You only have one direction to take. You can't just go from home base to third base and back to home. You have to go through it in a specific order. And if there's anything that blocks you from being able to complete that cycle, like the opponent being on second base getting ready to tag you out, right? You can't complete it. You can't get that you can't make it back to home. So it's the same way in a series circuit. So if we look at a very simple series circuit that just has a battery and 3 light bulbs in it. Okay. So this is a very simple series circuit that has a battery with 3 light bulbs in it. If any part of this circuit breaks, that electricity is going to stop flowing. So if the first, let's just call these light bulbs 1, 2, and 3. If light bulb 1 burns out, they all go out. Even though the other 2 light bulbs still work fine, the entire circuit turns off because there's no way for the electricity to make it through light bulb 1. Okay. This is like how most of the cheap Christmas tree lights are wired. And that's why if one bulb on that strand goes out, the whole strand goes out when it's the cheap ones. Okay, the more expensive ones are wired in a combination, which we'll look at next. Okay, the second type of circuit is a parallel circuit. In a parallel circuit, the electrons have more than one path that they can take. And so if one part of the circuit breaks, the rest of the circuit can still function fine. So if we look at a parallel circuit, okay, we oftentimes will draw this as a series of parallel lines because it kind of makes sense that way. So that's now light bulb 1, 2, and 3. Okay, so now if light bulb 1 goes out, the electrons can still continue flowing through light bulbs 2 and 3 because of the fact that they still have a full circuit to be able to get around. The other type of circuit that we have is a combination of series and parallel. So you'll have your there's one that's in series. Okay. So in this case, if light bulb 1 goes out, they all go out. But if light bulb 2 or 3 went out, only that light bulb would go out. And so that's actually how most of the more expensive Christmas tree lights are wired, because if one goes out, only part of the string goes out. Okay, the lights in like your classroom would be wired like the parallel circuit. So if one bulb goes out, the rest of the lights in the classroom still work just fine. So the next thing we're going to look at is moving into different things associated with electricity as well. So conductors and insulators. An electrical conductor is a material through which charge can easily flow. This would be any of your metals. There are other things that are good electrical conductors as well, but they usually contain a metal if they're not a metal. Okay, electrical insulators are materials through which charge does not easily flow. So these are things like plastic, rubber, wood, air, anything that's going to prevent the electricity from flowing. Okay. Superconductors are very cold solids that allow the conduction of electricity extremely well. So these are materials that are used in like supercomputers, those sorts of things that allow for very, very fast movement of electrons. And then semiconductors, if you remember way back to earlier units when we talked about metalloids, semiconductors are materials that only allow the electricity to flow when conditions are right, that doesn't flow all the time. So next we're going to look at what static electricity is. This is one of those terms that's often misused in everyday language. So static electricity is the study of the behavior of electrical charges. And we look at the ways that charge can build up and that charge can transfer between objects. We look at what happens when charge gets discharged suddenly, that sort of thing. And so anytime we're studying static electricity, we have to look at the law of conservation of charge, which says that the total charge before and after the transfer occurs must be the same. So if I start with an object that has a +2 charge and an object that has a -3 charge, the net charge there, the total charge, is -1. So after those two objects have interacted with each other, the total charge still has to be a -1. Okay, if I start with an object that has a +6 charge and an object that has no charge, the total charge there is +6. So after they've interacted, the total charge still has to be +6. So let's look at those methods of charging or discharging, building up and transferring charge. The first way is friction. In friction, you have some objects having a greater attraction for electrons than others. This means that those electrons are going to stick better, are going to want to go better to one material than the other. So when you rub two objects together, the one that does a better job of attracting those electrons becomes negative, and the other one becomes positive. So with friction, you start with two neutral objects. And you end with a positive and a negative. So example would be like when you rub a balloon on your head, and you can stick it to the wall then, or you walk across the carpet and you're building up a charge on your body, your socks sticking together in the dryer. All of those are examples of friction. Okay, the next method of charging is called contact. So when something that is uncharged comes into contact with something that is charged, part of that charge transfers, causing the object itself to become charged. So you either start with positive and neutral, which then becomes positive and positive, or you start with something that's negative and something that's neutral, and you end up with something that's negative and negative. So an example would be using a Van de Graaff generator. A Van de Graaff generator builds up charge through friction, but then it transfers through contact. The final method is induction. Induction is the transfer of charge without contact between the two materials. This occurs when positive and negative objects come near each other. So after you've walked across the carpet and built up the charge through friction, you reach for the doorknob and you get shocked, or you reach for your sibling because you think it's funny to shock them. Okay, so in this case, you start with a positive and a negative, and you end with neutral and neutral. The last thing is static discharge. Static discharge occurs when the pathway that allows charge to flow forms suddenly. Sudden is a key word here because if it's done on purpose, that's a circuit. So example again is getting shocked when you walk across the carpet, or lightning. So that's kind of our summary for our introduction to electricity.